is not the testing presentation. Yes, it's testing presentation, but it's not the presentation which prepared only for this test, because this is a presentation of real course model which delivered to the students who learn IT and biomechanics. And in this brochure there is a lot of information of this program, so I only decorate some slides with this model. So and also I understand that now we should start, and we play some kind of game. So you are students, I'm a professor, and I should present my course model, and if you come here and and would like to listen about this course with the aim to take it or does not take it, and in this situation I start with some initial description of this course. So we just now we start. Hello everyone. I'm an associated professor of the Department of Mathematical Modeling. My name Konstantin, and you could achieve me on the email address in this slide, and I would like to present the course model, Modern Numerical Methods for Mathematical Modeling. How to operate with this device?
You should to press the right button.
Okay. First of all, I'd like to present the common information of course model, and the idea of this course model is M2.P1, and you could find the description of this model in this brochure, in the course catalog. The workload of this model is 5 ECTS credits, and the status of this model is elective. Period, the first year and second semester, and language both English or Russian. So mode of delivery face-to-face, and the style of delivery is lectures and laboratory work, 4 hours per week, and some you will need some laboratory work, self-study, and provide written report, and the total amount of workload is 135 hours. Assessment grade from 2 to 5, and the percentage of your achievement will be 40% for final exam in written, and 30% for laboratory work assignments, and individual project assignments 30% too. Prerequisites is the bachelor level of your background, and course modulus of analysis, linear algebra, ordinary differential equation, partial differential equation, calculus, and some skills in scientific computing like MATLAB and Maple. Let's briefly consider the aims of the course module. We could discuss more some items. We could discuss more clearly if you ask me, but I would like to briefly said about the main aims, because this course model focuses to the how to say, to the tools of mathematical modeling, like boundary value problems, both for ordinary and partial differential equation, and some modern numerical techniques and methods for the computer-based solution for these boundary value problems. And my dream is to deliver to you the ideas of some different numerical methods, and analyze the good and worse sides of these methods, and to try to show you how to compare these methods between the whole set of different methods. Okay, the major emphasis is on study finite element methods with abbreviation FEM, and the reasons of this selection is because these methods well structured in the computer-oriented sense, and has a good and well described the scheme to implementation, how to implement this method, and it is very universal for different problems in complicated geometry, in two-dimensional and three-dimensional cases. And also we consider the very popular projection-based, Galerkin-based methods and techniques like Bubnov method, methods of moments, methods of least squares, allocation methods and its modifications, and we compare these projection-based methods with the grid-based methods like finite difference method and, as I said, finite element methods. Also, we will discuss some tricks when we realize these methods in the framework of MATLAB or C++ environment. So let's now move to the discussion of learning outcomes of this model, and on successful completion of the model you could achieve the ability to analyze different approaches to the discretization procedure for the typical boundary value problems, both for ordinary and partial differential equation, and could analyze the error estimation and algorithmic complexity for this procedure. I hope that you could apply and choose a suitable numerical method for given problem. Maybe not the very complicated, but regular second order problem, and could use the weighted residual approach for construction, the new modification of well-known methods. And also the quite important side of and feature of this course model is to train you to use math packages and demonstrate individual thinking and ability to individual work and independent thinking through the preparation of the individual project as a course task, course model task. So then we could analyze content of this course model, but just now it seems to me we only briefly observe these aspects, because as I said, this information you could find in the course modules and program master program description. So this is the items of the content of the model, and it's quite big and detailed, and all of these items connect with numerical methods and some specific features of these methods, and at the period of the course model is splitting on two parts. In the first part we will learn about the projection methods, and in the second part about the grid-based methods and finite element methods. So this is the course content overview, and study material include the obligatory reading. In this slide there are obligatory reading and some additional readings. Also, you could use the internet resources which presented in this slide. Okay, just now we finished the overview of course description, and I would like to move to the first unit of this course, the introductory unit, and the title of this unit, role of mathematical modeling and computational experiment in natural science and engineering. First of all, the outline of this unit, discuss computational experiment and numerical simulation as a tool for studying natural phenomena and technical phenomena. And here we discussed what tools we know for studying natural and technical phenomena. We analyze new reality in the our industrial life and in our natural life. I would like to show you some information, to deliver you some information about historical issues on this topic, and we analyze the concept of computational experiment and to determine the place this course model in the context of the computational experiment. First of all, let's discuss the tools for studying natural and technical phenomena. We could select four main approaches for this research. First of all, natural experiment. Natural experiment means to provide natural experiment, it means that we observe the natural phenomena and collect data, and then to process some statistical characteristic of this data and this analysis. In this case, we have a small amount. We could not to affect to this phenomena very hard and very strong. The next tool is a laboratory experiment, and here we should apply the theory of similarity, and in this case we could plan this experiment and to try different options and so on, but we spend a lot of time to prepare such kind of experiment. The strong side of this approach is that we could analyze the phenomena as a whole. The next tool is the mathematical modeling on the base of analytical solution of the mathematical problems. And this approach is very powerful, but only for the problems which we could solve analytically. And the last one, too, the mathematical modeling on the base of numerical solution and by using computers. This is maybe more universal and common approach, and in this case we could very fast modify the conditions of our processes and to provide different and to test different hypotheses about our phenomena. So, what is a new reality? First of all, now we should solve more and more complicated problems. The complexity of this problem connects with non-linearity, with complex geometry, with large scale and three-dimensional analysis, and the complicated problems what we should solve as a rule need some optimization procedures with many parameters. The second new feature of our reality is a big progress in numerical methods and the progress in hardware and software. I mean computers and packages and computer packages for solving such kinds of problems. So this new reality shifts us to the implementation more and more the mathematical modeling and mathematical simulation and computer simulation. Okay. Now I would like to tell you about some historical issues, and it's very interesting situation. All of you are very young guys, and you don't know about the Soviet period of our country and the meaning of some specific journals and newspapers like Communist or Pravda, the journal Communist, or a newspaper Pravda, and but I try to explain you the influence the publication is in these sources, the ideas about the computational experiment and mathematical modeling and so on. How to say, the idea of computational experiment, it's not a young idea, and the famous scientists like Euler, Lagrange, and many great names of scientists used the techniques of mathematical analysis and solution of equations for investigation the phenomena. But the words computer experiment connect many authors connect this term with the name of academician Samarsky, because academician Samarsky provided several articles, several papers in not in this scientific journals, but in the public journals, and here I collect some specific, not the all, but some specific articles in the journal Communist and in the newspaper Pravda. In that period, to publish publication in such sources means that the policy in science, in the funding and sources and funding and support of the field of science shift very hard to this direction. So in the period in 18 years in the previous century, such shifting was done, and new institution, research institution, new programs were launched in the Soviet Union. And what means this idea, the academician Samarsky idea, the idea of computational experiment. This diagram shows the idea of computational experiment, and we have 6 stages. Maybe it's not so important to split all cyclic and iterative process on 6 stages, but the main stages are described on this diagram. First of all, we start with so-called physical model, when we describe the phenomena, maybe in words, maybe as some fundamental laws, like conservative laws, and after that we comes to the mathematical model, when this description we try to write as an equation and condition on the mathematical language. After that we comes to the discrete model. We use specific discretization procedures and received the equations like matrix equations and system of ordinary differential equation and Cauchy problems for this kind of systems. And then we provide and prepared the computer program on the base of a numerical algorithm and the programming languages or packages or so on. After this, we come to the stage when we provide the numerical simulation and collect the numerical data and information about these phenomena in spite of our representation it as a mathematical model. Then we analyze this information, this data, and provide some conclusions about the physical phenomena and try to understand is it right or not. It could be three options in this situation. First of all, we could receive a result which are in contra with our physical representation or our understanding of these physical processes and some fundamental laws. In this situation, we should search the mistake in different stage, maybe in numerical solutions, maybe in the computer program, or discrete model, or mathematical model. So this is a process which we apply like iteration. The second option, when we receive results with good correspondence to our representation or our knowledge about the natural phenomena. In this situation, we provide some maybe research paper in journals or some recommendation to our industry partners or industry partners or some technical devices and so on. And the third option could be the disappointed with our knowledge about the physical model, but this could be the sign that we find the new phenomena, the new knowledge, and in this situation we could receive outstanding results and to provide some new understanding of the phenomenon. The results, the very good example of this situation is the discovery, the Pluton by the Kepler. No, sorry, not the Kepler. I forgot the name of the science.
Plutonium by
Kepler. Yeah, Leverrier. Okay. Yes, thank you very much. And this is a pure example where the mathematical calculation shows the place of new planet, and then astronomists could find this planet in the sky. And we know several examples, maybe not so impressed level, but it's very pictorial for demonstration the abilities and strong sides of this approach. So just now time is over, and I think that we could return to our discussion on the next day, and I hope that I will see you, maybe the majority of you, in the audience. Thank you very much. If you have any question, I would like to answer your questions. Yeah?
Konstantin Arkadyevich, I have small criticism regarding this diagram. I think you mean by discrete somewhat opposite to the continuity.
Yes.
But you should write this in a different manner. Discrete. This means, this discrete means accurate.
I'm sorry, it's mistaken. I'm sorry, yes.
The spelling mistake. Ошибка
Yes,
написана.
yes.
Spelling mistake.
Thank you very much.
Okay. So any other questions? No questions? Yes.
Very
Because
comprehensive.
Konstantin Arkadyevich has worked very hard and he has prepared a real lecture, so with big content and with a lot of facts and